1. Bridge Brief Introduction. The max span of this project is 45 meters. Minimum span is 30 meters. Max longitudinal slope is 6%, and max transverse slope is 6.6%. Applying span by span construction method. Maximum full span net weight for hanging on LG is 685 tons. Minimum radius is 152 meters. Precast segments dimension: length 3 meters, width 13.95 meters, height 2.4 meters. Maximum weight of segment in 110 tons. 2. LG Brief Introduction. Based on our vast experience in the bridge construct fields, LG700t to 40-meter span-by-span launching gantry is specially designed according to viaduct of Highway Route number 35, Contract 3, using requirements. LG700t to 40 meters is capable of construct precast segmental bridge with span no more than 40 meters. Rated capacity and 700 ton. The launching gantry mainly consists of main truss, supporting structure, hoisting system, hydraulic system, and electric system, etc. Supporting structure includes front leg, front middle leg, rear middle leg, rear leg, pier bracket, and pier side bracket. Hoisting system includes 1 unit 120-ton winch trolley and 1 unit 10-ton overhead crane, capable to pick up the segments from the front or from the rear and bottom of launching gantry. This LG integrates advanced mechanical, electrical, hydraulic system, support system equipped with hydraulic jack, which is convenient for adjust the height of supports. Launching gantry safety protections. 120-ton winch trolley designed with overload protection will alarm when the load reaches to 90% of the setting value, unable to lift up when load reaches to 105% of setting value. Hoisting system also designed with the height limiter. The upper height limiter can effectively prevent the pulley block rising to the height limited position to protect the wire rope. Lower limiter can prevent the lifting beam landing on ground. Assure the wire rope always in tension state, which can avoid the wire rope skip from rope drum or pulley block because of slack. The rope drum is equipped with 2 brakes. One brake located on high-speed shaft and second brake is installed on the flange. Second brake and overspeed switch cut off the power when the wire rope glide or overspeed 20%, and the second brake active within 0.2 seconds for safety protection. PLC will send the signal to cut the hoisting signal when overspeed, and the disc brake will activate at the same time to prevent stall with load. Main truss equipped with 4 sets hydraulic self-lock and 4 sets mechanical lock to prevent main truss sliding during launching. The hydraulic system of the front leg, middle leg, and rear leg is independent. Movement of each support leg, like jack-up, longitudinal moving, and transverse moving, can be controlled in synchronized or independent, which is convenient and flexible. Winch trolley and overhead crane, both mounted with the anti-drop device and windproof anchorage. The launching gantry also designed with a nemograph, travel limit switch, and emergency stop switches. The segment lifting spreader is capable to rotating plus or minus 180 degrees rotation, while the lateral and longitudinal cylinder on spreader is designed for fine adjustments, 3-dimensional status, to control the alignment and bridge routine precisely. 3. Main components. 1. Main truss automatic launching system. Equidistant stopper are mounted along the bottom of main truss. The hydraulic launching cylinders, located on middle leg, is designed for launching main truss forward and backward by pushing the stopper. The launching direction can be changed by the pin position at the sliding block of launching device. When launching forward, insert the pin in the front hole of sliding block. The cylinder push main truss forward 1 stroke, then retract the cylinder. The cam wheel of the sliding block will pass the stopper automatically. Repeat above operation steps to launching the main truss step by step. When pulling main truss backwards, the pin should be pulled out and inserted in the rear hole of sliding block, and pulling the main truss back by the same principle. 2. Self-lock system of main truss launching. The self-lock device is such a system that the cylinder drives 2 eccentric gear to clamp main truss. When launching movement, stops or release main truss during launching to avoid main truss sliding. Self-lock is a normal closed device. When longitudinal launching cylinder acting, the load of cylinder is increasing gradually, and the hydraulic system pressure will be increased automatically when pressure reaches set value. The self-lock release main truss when pressure reaches a higher set value. The longitudinal cylinder starts to activate. The left and right longitudinal launching synchronization is controlled by the synchronous valve. The maximum synchronization error is about 10%, which will be automatically correct within 1 working stroke. After 1 working stroke, the longitudinal cylinder unload, and hydraulic pressure decrease immediately. The self-lock will clamp the main truss. 3. Mechanical lock. Mechanical lock installed on the longitudinal sliding block. Operator can manually adjust the space between lock's broke plate and main truss to assure brake reliable and prevent main truss sliding. Operator needs to pull out the lock pin before main truss or middle leg needs to move. 4. Front leg, middle leg, and rear leg travel system. All the support legs designed with motorized wheels to traveling along the main truss lower cord. The roller is also acted as the locking system between legs and main truss. The roller can prevent the main truss drop. 5. Middle leg transverse shift. By using the transverse moving system together with longitudinal moving system to assure the launching gantry past the span with radius and merging area. The transverse cylinders push or pull the upper structure of middle leg to move the main truss. On the middle leg crossbeam, there are designed with equidistant pinholes and stainless steel plate for sliding operation. Equidistant pinholes and stainless steel plate on the middle leg crossbeam for sliding operation. 6. Winch trolley transverse movement. The upper structure of 120-ton winch trolley is capable of transverse shift by cylinder to adjust the cross position of segment. 7. Power supply method. The support legs and hoisting system are all powered by conduct rail, which is easy for mobilizing LG and support legs. 8. Anchorage system. Middle leg is tied down with segment by 4 pieces PT bar, 4 pieces of anchorage beams, and 2 pieces distribution beam, which can suit for anchor with various segments. Pier bracket tied down with pier head by 4 pieces PT bar. Pier side bracket anchored to pier head by 12 pieces PT bar. The rear leg will be fixed on main truss by bolt to avoid any sliding when it is not moving. The main hoist and overhead crane traveling adopt motor with brake to ensure the parking reliability. 4. Construction method. 1. Continuous span construction. LG finished erecting the segments and ready for launching forward to next pier. Retract rear leg to move to the end of main truss. Launching main truss forward by hydraulic cylinder until front leg reaches next pier head. Use 10-ton service crane to lift and install the pier side bracket. Then 10-ton service crane move backward to nearby rear leg. Retract front leg to driving forward 1.95 meters to load on the pier side bracket. lifting the pier segments of continuous span by 120-ton winch trolley. Jack up rear leg to make rear middle leg hanging on the main truss. Rear middle leg move to nearby front middle leg. Disconnect the pier bracket and front middle leg. Jack up rear middle leg to make front middle leg hanging on main truss. Front middle leg move forward to next pier and load on pier segments. Then use 120-ton winch trolley to take off the pier bracket. Tie down rear middle leg and front middle leg. Retract front leg and rear leg to launching main truss forward 21 meters. Dismantle pier side bracket by 10-ton service crane. Erecting the segments of the continuous span. Then install the stressing platform of middle leg to stressing full span. Dismantle the stressing platform and hanging frame after full span tension is finished. Front leg move backward 1.95 meters and bolted on the main truss. Prepare for launching LG forward. 2. Simple support span construction. LG finished erecting the segments and ready for launching forward to next pier. Retract rear leg to move to the end of main truss. Launching main truss forward by hydraulic cylinder of middle leg until front leg reaches next pier. Use 10-ton service crane to lift and install the pier side bracket. 10-ton service crane move to nearby rear leg. Front leg retract and driving forward 1.95 meters to load on pier side bracket. Jack up rear leg to make rear middle leg hanging on main truss. Then rear middle leg move to nearby front middle leg. Jack up rear middle leg to move front middle leg forward together with pier bracket to next pier. Tie down rear middle leg and front middle leg. Retract front leg and rear leg to launching main truss forward 21 meters by hydraulic cylinder. Dismantle pier side bracket by 10-ton service crane. Erecting the segments of simple support span. Dismantle the PT bar and hanging frame after finished full span tension. Front leg move backward 1.95 meters and bolted on the main truss. Prepare for launching LG forward. 3. Slope working assumption. LG700t to 40 meters can construction the bridge with max 6% longitudinal slope. Operator must adjust the main truss slope less than 1.5% before lifting the segments. 4. Curve span working assumption. 1. LG erecting the segments of span with radius by span method. 2. Move winch trolley nearby front middle leg. Dismantle the anchorage of rear middle leg. Jack up rear leg to load on segment. Retract rear middle leg to move forward, then adjust crossbeam position. Jack up rear middle leg, leveling to horizontal and tie down. 3. Retract rear leg to hanging on main truss. 4. Move winch trolley in the middle of second middle leg. Shift the main truss 4,466 millimeters to right by front middle leg, and shift the main truss 4,217 millimeters to left side by rear middle leg to make the main truss turn 12.33 degrees. Front leg aligns to the center of next pier head. 5. Move winch trolley nearby rear middle leg and rear leg move backward. 6. Start longitudinal pushing cylinder of both middle legs to launching main truss forward until front leg load on pier side bracket, rear leg load on pier segment, then leveling front leg and tie down. 7. Retract rear leg to minimum height to make main truss gradient in 3.7%. 8. Rear middle leg move to nearby front middle leg and tie down to segment. Front leg load on pier side bracket. 9. Move front middle leg nearby front leg. 10. Winch trolley move to nearby rear middle leg, then retract rear leg. 11. Rear middle leg shift left to make LG gravity center align with middle leg gravity center. 12. Jack up rear middle leg. Move rear leg nearby rear middle leg, then leveling main truss by rear middle leg. 13. Launching main truss forward. 14. Transverse shift the crossbeam of front middle leg to left, and transverse shift the crossbeam of rear middle leg to right. LG, prepare for erecting the segments. 15. Start the motor of the rear leg roller to move the rear leg nearby rear middle leg. Jack up rear leg and retract rear middle leg to shift crossbeam of rear middle leg to left. LG finish to pass the span with radius. The procedure of ramp working assumption is similar to the LG construct the span with radius. Surely, HLCM's LG700 ton 40-meter launching gantry will be your cost-effective choice.